Hi, everybody. This is Mr. Folly. Ooh, my pen's not working. And welcome to our last podcast of the unit. Woo. But this is the mathiest, mathiest of it. So make sure you get out your calculator and your periodic table so we can do molar masses. So let's hop right to it. All right, so limiting reactant. So we're going to talk about a reactant that limits the amount of product that forms, okay? So if I own a tricycle company and my tricycles have 3 wheels for every 1 frame, if I was super nerdy, I would go 3 wheels plus 1 frame yields 1 tricycle, right? So how many tricycles can I make if I have 9 wheels? Well, 9 wheels tells me I can make 3 tricycles. 2 frames tells me I can make 2 tricycles. So can I make 3 or can I make 2? I can only make 2 tricycles. Why? Frames limit the amount of tricycles I can make. All right. Now, if I have 9 frames, I can make 9 tricycles. And if I have 3 wheels, I can make 1 tricycle. Oops, 1. So how many tricycles do I make? I can make 1. And that is my limiting reactant would be wheels. Wheels limit. Right? If I had more wheels, I could make more tricycles. Okay. All right. Now let's do chemistry, the one that really matters. So what I'm going to do is, in an experiment, I have 3.25 grams of NH3, and I have 3.50 grams of O2. Notice last time we just gave you 1 to convert. What we have to do is find the limiting reactant and find the mass of NO formed. The second one usually tells us what we want to convert it into. So I'm going to convert NH3 into NO, and I'm going to convert O2 into NO. And when I do that, I'm then going to pick the smaller amount, okay? So here we go. I have 3.25 grams of NH3 times dividing bar, and then grams of NH3, which is 17.04 grams. I go to the periodic table and 1 mole of NH3. And then I'm going to take, remember I said I'm going to NO, and I want grams of NO. So then I'm going to put moles of NH3 on the bottom to get out of that, and go into moles of NO. And moles over moles use coefficients, so 4 over 1. And then I'm in moles of NO, but I want grams, so 1 mole of NO to grams of NO. And little g means grams, and little g means go to the periodic table. So nitrogen is 14.01, oxygen 16, that's 30.01. Let's get an answer, 3.25 divided by 17.04 times 4 times 30.01 is quit, error, go to. So that's not good. So 3.25 divided by 17.04 times 4 times 30.01, I get 22.9. Now, this is the most that NH3 can make. Okay, so now, oops, it didn't grab for me. Gonna make it a little smaller so it can fit. Okay, so now I'm going to do basically the same thing, but I'm going to start with my 3.5 grams of O2. 3.50 grams of O2. Again, converting it into the exact same thing. I know it seems weird, but we're going to go grams of NO. So get out of grams of O2, always go through moles, always go through moles, always go through moles. 32. And then moles of O2. I'm trying to go into grams of NO, so first I have to go into moles of NO. Moles over moles use coefficients, 4 and 5. And then I'm going to get out of moles of NO and go into grams of NO. I know it's not much help, but the last couple of steps are really close to the same, so I don't have to look up the molar mass of NO again for it. Just want to remind everybody that even though this is a 4, this part right here is 1 mole and 30 grams. And the reason why is they have to equal each other. If I had 4 moles, it takes more grams to be 4 moles than 1. Math. 3.5 divided by 32 times 4 divided by 5 times 30.01 is 2.625. So 2.625 0.63 grams of no. Now, how much is made? This much is made because it's smaller. Okay, my limiting reactant is not 2.63 grams of no. It is, 3.20. It is my reactant that gives me that much. I lost my page. Yeah, because I went the wrong way. It is my limiting reactant, is the reactant that gave me that much, 3.50 grams of O2. And notice it's kind of weird. In this case, even though 3.5 is larger than 3.25, it made less. Okay. And then this tells us the mass of NO that is produced. Okay. What I'm going to do, I know this sounds weird, I'm going to skip this one because I know it's going to go long. And I'm going to do the excess reactant because I have to do a limiting reactant on it first. Okay. Oh, wait. No, actually, I need to do this limiting reactant. Probably do the other one. Good. So a reaction container holds 5.77 grams of P4 and 5.77 grams of O2. The following reaction occurs, blah, 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 blah. What is the limiting reactant formation of P4O10? And what mass of P4O10 is produced? So I'm going to convert them both into grams of P4O10. Okay? So I'm going to start right here with 5.77 grams of P4. Okay? I'm going to convert it into grams of P4O10. So grams of P4, 1 mole of P4. Always go through moles. And phosphorus is 30.97 times 4. So 123.88. I'm in moles of P4. And I'm going to go to moles of P4O10. So notice this has a coefficient of 1 and this has a coefficient of 1, so that doesn't change anything. And then 1 mole of P4O10 and go to grams. So 4 phosphoruses are 123.88 plus 10 oxygens plus quantity 16 times 10. Why did I put that in there? Plus 160, so 283. And that's going to be, whatever this number is, 5.77 divided by 123.88 times 283.88 equals 13.2. So 13. Now I'm going to do the same thing for my O2. 5.77 grams of O2 times dividing bar, grams of O2. Go to the periodic table. 1 mole of O2. Moles of O2. Grams of, not grams, what am I doing? So I'm trying to go into grams of P4O10, right? Remember, that's my goal. Grams of P4O10. So before I can go to grams of it, I have to go into moles of P4O10. And then moles over moles use coefficients. 5 is a coefficient for oxygen, 5 is oxygen, 1 is P4O10, times 1 mole P4O10, and grams of P4O10. Luckily, I already did this molar mass. 0.88. Let's get an answer. 5.77 divided by 32 divided by 5 times 283.88 is 10.2 grams P4O10. So how much is really formed? 13.2 or 10. This much is really formed. Okay? And that means my limiting reactant is the reactant that gave me that 5.77 of O2. And really, O2 is my limiting reactant, is O2. All right, so if one substance runs out, the other must be left over. The word for leftover is excess. Okay, this is done on purpose to make sure we use all of the expensive reactant. So a lot of times there's 2 parts, one's expensive, one's not. To calculate your excess, find the limiting reactant as above. Hey, we're good at that now, I think. Convert the limiting reactant into the excess reactant. This is the mass of excess actually needed. Subtract the needed from the given amount. Okay, well, let's just do some, okay? A reaction that holds this, so this is the same one from above, okay? The limiting reactant was O2. Find the excess reagent. So what do we do again? So we have the limiting reactant. We're going to convert the limiting reactant into the excess reactant. So that means I'm going to convert O2 into P4. 5.77 grams of O2 times 1 mole of O2, 32 grams of O2. Remember, I'm trying to go into P4, times 5 moles of O2 and 1 mole of P4. Got to go into grams. 1 mole P4. And I forgot the molar mass. 30.97 times 4, 123.88 grams. So this will tell me how much I need. 5.77 divided by 32 divided by 5 times 123.88. And I need 4.47 grams needed of P4. But notice I have 5.77 grams. So how much extra do I have? Well, that's why I subtracted. 5.77 minus 4.47 equals 5.77 minus answer is 1.30 grams of P4 excess. Yeah, I got leftover, right? Does that make sense? I've got 1.40 grams of P4 left over. Okay? All right. An experiment, 3.25 grams of aluminum react with 3.50 grams of oxygen. The limiting reagent was O2. So that means I'm going to convert O2 into NH3 in grams and then subtract 3.50. So I'm cutting out that limiting reactant part, O2 times 1 mole over 32 grams of O2 times moles over moles, moles O2, moles NH3. Moles over moles use coefficients. Oh no, it's not balanced. So let's do that. That gives me 6 hydrogens. That gives me 6 hydrogens. That gives me 4 oxygens. That means I need a 2 here. 2 NH3 and 2 O2. And then I change that to grams. 1 mole NH3. Go to the periodic table. Grams of NH3. 17.04. 3.5 divided by 32 times 2 divided by 2 times 17.04 is 1.86 of NH3 is needed. Now notice we have 3.25. So I have 3.25, have minus need equals excess. I have 3.25 minus 1.86 equals 3.25 minus answer 1.39. Whoa. Okay. Yeah. All right. Stoichiometry and limiting reactants with pictures. Same idea, but count and compare. Write the reaction, pay attention to the coefficients as they help determine how many there are at the end. So if I have this, I have N2 plus 3H2 yields 2NH3. Okay, so N2, it would have to tell you are the big ones, and H2 are the little ones. Little, okay? So 1 N2, ba-boom, needs 3 H2. Doink, doink, doink. 1 N2, ba-boom, 3 H2. Doink, doink, doink. N2 is excess. Why? I got a green one left over. That's it. These are really questions. What is, okay, if white circle is H and black circle is C and gray circle is O, write the reaction. Okay, so see this guy right here? That means it's going to be C2H, see those two, 1, 2, 1, 2, 3, 4, 5, 6, H6 plus, this is what's left here is O2, O2, right? O, is going to give me CO2. Hey, it's a combustion reaction. Plus, hey, that's Mickey Mouse water, H2O. Okay? So on this, if I were to balance this, so there's 2 ways you can balance it first. Let's go ahead and do it that way. If I put a 2 here and a 4 here, and there's 4 carbons, that's 12 carbons, that'd be 6. Maybe I don't need this many. 8 plus 6, 8 plus 6 is 14, so this is 7. Okay, so what that means is for every 2 of these, 7 of these will go away. 1, 2, 1, 2, 3, 4, 5, 6, 7. Do you see how both reactants are limiting? Because there's none in excess. Pretty cool. Which means I should get 4 CO2s, 1 little, 2 little, 3 little, 4 CO2s, and 6 waters, which is what I have. All right. I'm going to skip that one because I want to do this part and be out of here. Most reactions do not react completely. Like we get A's, but we don't always get hundreds. Oh. Percent yields are consistent. If H2 plus O2 gives you an 82% yield on Tuesday, you will likely get 82% on Wednesday, and 82% on Friday, and 82% next week. Okay? So the formula is the actual yield, which, by the way, is what the lab says you get, divided by the theoretical yield, which is what math says you'll get. Okay? So lab result over stoich, meaning math result. Sometimes you ask for error instead of yield. So if I have a 97% yield on the test, I have a 3% error. Super simple, right? So you just subtract it. All right. Glucose decomposes into ethanol. Let me get myself a little bit more space here. Glucose decomposes into ethanol and above. And carbon dioxide is shown below. If 6.5 grams of C6H12 makes this much, what's the percent yield? So what I'm going to do is I'm going to take this and convert it into the one I have a number of. Isn't that weird? I know it's 2.55, but how much should I get? So I'm going to do this in grams. So 6.5 grams of C6H12O6 times 1 mole C6H12O6 and molar mass. So 6 times 12.01 plus 12.12 because hydrogen is 1.01 plus quantity 6 times 16, close quantity, and I get 102. That's not right. Oh, I did 6 minus. 6 times 12.01 plus 12.12 plus quantity 6 times 16, 180.18. 180.18 grams of C6H12O6 times moles of C6H12O6. I'm already tired of writing it. Coefficient of 1. And I want to go into moles of C2H5OH. Coefficient of 2. Moles over moles use coefficients. Times 1 mole C2H5OH. And over here, grams C2H5OH. 2 times 12.01, that's carbon, right? And enter. Plus 6.06. Notice I have 2 batches of hydrogens. Plus 16, and that's 46.08. And this will tell us how much, if everything is perfect, it's not, I should get, right? So in your final exams, you should get 100%, but really, we don't. 180.18 times 2 times 46.08 is 3.32. So I should get 3.32 grams of C2H5OH, but I didn't. I got 2.55. What's the percent yield on that? So looking right here, my actual yield is 2.55 over my theoretical yield, which I forgot already, 3.32 times 100 equals 2.55 divided by 3.32 equals 0.76. Times 100 would be 76.8. Ugh, almost a C plus, 76.8%. And there you go. And that's it. And to that, I will say, toodles.